Okay. Hello, everyone. My name is Federico Tenga, and I work for Bitfinex, where we have a RGB-focused team, where we actually try to achieve a bunch of stuff. Our goal is basically to just facilitate the development of the RGB ecosystem. So far, we don't have any specific business goal. We are not building any market-oriented product. We are just trying to, indeed, facilitate the development of an RGB LT ecosystem. We do this in various ways. We contribute to the protocol with PRs, testing, bug fixing, etc. We build numerous developers tools. The most interesting one is RGB Lib, which is a library to build RGB wallets in a simple way without having to understand all the internals of RGB, which are quite complex. We released a wallet. It's called Iris Wallet for Android. You can find the testnet version on the Play Store. We built a RGB compatible Lightning node, which we will discuss a bit about it today. And we also try to support other teams that are building on RGB, and in particular with our developers tools. This is Iris Wallet if you want to try it on the store, but it's not the focus of today's presentation. What we will talk about today is specifically about the Lightning part, and why do we need assets on Lightning, and at least why some people are interested in assets on Lightning, and how we can achieve that. So first of all, the problem, why do we even need all of this? There is clearly a demand for peer-to-peer payments with stablecoin and other, let's say, derivatives on traditional assets. And right now, probably there are much more payments in retail and in general payments in USDT and other stablecoin compared to Bitcoin, because it's just easier for people not to have to deal with Bitcoin volatility. Of course, Bitcoin is the real long-term solution. Otherwise, if stablecoin were enough, we wouldn't need Bitcoin. But in the meantime, especially in a transition period where people still need to get used to this technology, it appears that stablecoin payments are more interesting for the market than Bitcoin payments. I believe that this will change in the future, but for now, this is what the market is asking. There are currently the only available solutions for stablecoins are on altcoins and other blockchains, and I guess I don't need to spend time explaining why it's not desirable to use other altcoins. I mean, of course, they offer trade-offs that may be acceptable for some people, but for sure they cannot offer the same level of security and decentralization that Bitcoin offers. They offer a trade-off. Maybe it's okay, good enough for some use cases, but for sure it doesn't offer everything that Bitcoin and Lightning can offer. Other Bitcoin-based solutions have existed. They were also actually they existed for a while. The first solution to tokenize assets on Bitcoin are actually over 10 years old now, with Colorcoin, Counterparty, OmniLayer, and they kind of failed. They failed for several reasons, and one of that is technical reasons, because they were developed in too early. So they were developed in an era where scalability was not an issue because all blocks were empty. Privacy was not really an issue because everybody thought that Bitcoin was perfectly anonymous by itself, and Lightning didn't exist, Segwit didn't exist, Taproot didn't exist, so they just couldn't leverage all the evolution that Bitcoin had over the years. So what are the desired features for a truly decentralized asset transfer protocol? First of all, to be based on a blockchain that is secure and truly decentralized as Bitcoin is. Second, it needs to be sustainable to be used on consumer-grade hardware. So if we ask users that on top of their Bitcoin node, they also need to run another node that is very resource intensive, as it was the case with some of these earlier protocols that I mentioned, it doesn't really work. Then, for example, with Counterparty, at the end, everyone was just all the users were just using the web wallet and they weren't even really running a node. And yeah, why maybe good enough for some people, you kind of miss on the decentralization feature, and you're relying on a third-party server, so it's not ideal. So you really need the user to be able to run everything on a consumer-grade hardware. So since we are building on Bitcoin, the goal is to not to have extra requirement, significant extra requirement, other than the one needed to run a Bitcoin node. Second objective, this needs to be efficient in the usage of the on-chain space, because as we understood over the years, on-chain space is very scarce, and it can be quite expensive when there is a lot of demand for it. So, okay, we need to use on-chain space if we want to leverage the Bitcoin security, because of course it's the only way to do so, but we need to be as efficient as possible. Then of course we want to be compatible with the Lightning Network, because Lightning Network is currently the only, let's say, production-ready scalability solution for Bitcoin. There are other proposals, and yeah, we all look forward for them to develop, but currently Lightning Network is the only thing that people can actually use in the real world. So it is particularly important to leverage the Lightning Network. Otherwise, yeah, we can do some on-chain transfers, but yeah, for sure we cannot do payments on chain, or yeah, maybe we can do when fees are very low, but it's not really sustainable. And last but not least, yeah, it's nice to have some extra programmability features, so you can add some extra validation logic in the transfers that you're making. So this is how RGB try to provide all of these desired features, and it does it in a very new way. It employs this new design. I mean, the idea of the client-side validation is not new. It's been around since 2015, when Peter Todd first published his idea, but it's never been implemented so far. Until RGB came around. So the idea of client-side validation is completely different from what you have with any blockchain, any, let's say, global ledger-based system. So instead of all the information regarding a transaction, they're not published on a global ledger where everybody can see it and everybody can validate it and see what's happening. But they're shared only between the peers that are involved in the transactions. So, as it should be, I mean, why do I need to see what the transaction of other people that is not me? I mean, like, why do I need to be able to see the financial activity of other people? It shouldn't be the case. I should be able to see only what I'm doing. And so other people shouldn't be able to see what I'm doing, because, yeah, it's nice to have some privacy over your financial life. And this is, I see, a flow of blockchains. It's a necessary flow, because, I mean, this is... what is something that you need to have all the features that the Bitcoin blockchain can offer, but still I consider it a flow. So if we can avoid pushing all the information to the blockchain and move them out of the blockchain so other people cannot see it, we gain on privacy, but we also gain in validation cost, because I don't need to validate anymore the transaction of other people that I don't care about. When we run a Bitcoin node, we basically, most of the time, we validate the transaction that will never be relevant for our Bitcoin wallet or for our financial life. So if we can, if we create a asset transfer protocol, take this away from the blockchain. So instead of bloating the blockchain with all the information about an asset transfer, we take it out of the blockchain. We not only gain privacy, but we also save on validation costs, because we don't need to validate the asset transfers of random people. So what do we need the blockchain for at this point? For double spending protection. There is no better way than the Bitcoin blockchain to protect from double spending. So all this information about the transactions that we're doing, if we are transferring, for example, USDT or any other asset or stablecoin, we can keep them out of the blockchain, but they need to be committed inside a Bitcoin transaction. Otherwise, we cannot leverage the double spending protection that Bitcoin can offer with all this decentralization and mining distribution. So the way RGB works is that each RGB transfer is committed inside the Bitcoin transaction, and this way we can leverage all the security feature of Bitcoin with no trade-offs. So it's not like a side chain where you have a trade-off that you have a little bit of, you need to trust a federation somehow, but you get some advantages. Not with RGB, you just get the same security model of Bitcoin as it is, because we just build RGB transfers on top of Bitcoin transactions. So the difference in the paradigm is that in a global ledger, everybody puts all the information on the blockchain and everybody sees everything, while in client-side validation model, we only share information and validate information between peers. So when I pay you, you will validate that what I'm sending you is valid. So you will run my transfer to you through the to the transfer validation software, and you will decide if what I'm giving you is valid or not. But you will do it only, but you don't need to do this with every random transaction that people are doing and that they're sharing on a global ledger network. So to go a little bit more specific, this is the only technical slide, but I think it is important to have an understanding of what we are actually talking about. The way RGB works is that you first have an, let's call it an issuance contract, where we will define some information about the token, like the name, the ticker, the maximum supply, and yeah, maybe some extra validation rules, some extra metadata. Maybe you want to attach a PDF, I mean, whatever. You define what you are issuing. But then you also define who is going to be the first owner of this asset. Somebody needs to be the first owner. How do we define ownership in RGB? RGB assets are always allocated to a Bitcoin UTXO. So if you have the ability to spend that Bitcoin UTXO, in this example UTXO A, then you have the right to move the asset. And it doesn't matter what is the script behind the UTXO. It can be like a single sig, a multi-sig, a Lightning channel, a bit VM taproot output, like whatever you want, it doesn't matter. You just need to show that you have the ability to spend the UTXO, and if you do that, you can move the asset that were allocated to such UTXOs. And how do you prove ownership? You spend it. So if when you want to move your token, you need to create a Bitcoin transaction that spends the UTXO that had the asset allocation. So in this case, the UTXO A. And you say, where do you want these tokens to go? So you have 100 tokens that were allocated to UTXO A. And yeah, in this case, the guy, let's call it Alice, wanted to pay Bob that had the UTXO B. So he sent 20 tokens to UTXO B and 80 tokens back to a change UTXO because yeah, when you spend on UTXO, you cannot spend it partially. You need to spend it fully. So you also need to prepare a second UTXO where you get the change of whatever you don't want to send to your counterparty. So this message is this ownership transfer is like a message. It doesn't go on the blockchain. It stays outside of the blockchain, but is to make it simple, say hashed and put. Actually, there are Merkle trees. Is a bit more complicated than that. But let's say that we hash it and we put it inside one output of the Bitcoin transaction that is spent in the UTXO A. And this is we need to do this to make sure that we cannot make it twice. We cannot create two ownership transfer to two different people. We create a commitment, so we cannot do it twice and we cannot double spend. And then, yeah, now at this point, now I will share this ownership transfer that doesn't go on the blockchain. I will just share it privately with my counterparty. It can validate that everything is okay, that input and output match, that so there is no hidden inflation. We respected the validation rules, and UTXO A was actually spent in a transaction that is confirmed on the Bitcoin blockchain. And at this point, the receiver can be sure that the transaction is finalized and he will actually be able to spend the money in the future, and then he can do a similar transfer towards his next counterparty using the same mechanism. But that is how it works on chain. But we know that on chain is not good enough because yeah, we are limited by needing to do a Bitcoin transaction for every RGB transfer. And actually, already there you have some scalability feature because you can do a lot of batching. I will not go into details, but basically with inside one Bitcoin transaction, you can create a RGB transfer that sends asset to many people. So you have a very good batching capability, especially if you're a service provider that you operate withdrawals to many people at the same time. But that's clearly not enough. Not only because it's expensive to use the Bitcoin blockchain, but also because it's slow. Nobody wants to wait 10 minutes on average to have finality on a payment. And usually when you are in Russia, those 10 minutes become 45 minutes. And so we need to absolutely leverage the scalability solutions offered by Lightning. And this is like when we started working on this is actually happened to be easier than we expected. Because at the end, RGB just adds meaning to a Bitcoin transaction. It doesn't use Bitcoin scripting. It doesn't need to do anything with the Bitcoin transaction. It just has a commitment to the Bitcoin transaction. So whatever logic you have in the Bitcoin transaction, you just say, okay, on top of the Bitcoin you're moving, you're actually also moving assets. So with Lightning Network is a quite complex protocol. You have all these channel updates with commitment transaction to make sure that like no counterparty can steal money from the other. But RGB doesn't need to, doesn't need to add extra complexity. It just says, okay, whatever is in the Lightning Network channel, there are some Bitcoins, there are a few Satoshis, maybe if you don't want to, if your goal is not to move Bitcoin, but just to move an RGB asset. And then whatever is and then you just add these assets to all the complex Lightning commitment transactions that you have. So you fully leverage Lightning security without changing the security model, without changing anything. You just say, okay, whatever, we trust that Lightning works, we believe that this channel is secure. We just added the meaning that these transactions are not only moving Bitcoin, but they're also moving RGB assets. So it is possible to modify an existing Lightning node to support RGB asset. And it's just a matter of how much modularity the Lightning node already has. But if it's already quite modular, it can be not so hard. So in our case, with our team, we build a Lightning node that supports RGB asset based on LDK. And LDK happened to be already quite modular, and it is also written in Rust, which is also the same language that we use for most of RGB stuff. So it came out quite nicely without having to, just by adding a little bit of modularity in the control of the commitment transaction of LDK, we were able to create an RGB-aware Lightning node that has the ability to create asset-denominated Lightning channel. So we can have a Lightning channel that instead of being denominated in Bitcoin, they're denominating in whatever RGB asset you are issuing. So yeah, stablecoin or whatever you want to do. Then at that point, you have a Lightning channel, it's denominated in RGB assets. You can move RGB asset with the same speed and convenience of Bitcoin on Lightning. And yeah, also all the flows of Lightning, of course. So yeah, you still need to manage liquidity. You will still have the little problem that you have when you use Lightning. Sometimes you still need to manage your node. So we don't change anything in that. It's just that on top of a Lightning node, we also have the ability to have the same experience that we have with a normal Lightning node, but with payments and channels that are denominated in other assets that are not Bitcoin. So this is already available. So you can go on our GitHub. We actually have a GitHub organization called RGB Tools, where we have all our developer tools, and we also have the Lightning node called RGB Lightning node, which you can try and yeah, you can create your own asset, issue it, and create a Lightning channels denominated in such asset. On top of that, it's once you have assets, multiple assets on Lightning, you can also create a decentralized exchange on Lightning, or an atomic swap protocol, where you can atomically exchange two assets on top of Lightning. And if you think about it, when you do routing on Lightning, you are actually already swapping asset. You are swapping Bitcoin that you have on one channel for Bitcoin that you have on another channel. But since we consider those different Bitcoin to be fungible with each other, we don't really call it a swap. But what if I receive Bitcoin on one channel, and on the other channel, when I do routing, I send another asset? At this point, I'm doing the same thing. I'm not doing anything different. But from the economic point of view, I'm operating a swap. I'm exchanging one asset for the other, but I still have the full atomicity of a Lightning payment. So either the payment goes through, or either the swap goes through, or it fails, just like with when you do routing of a normal Bitcoin Lightning payment. Either it goes through, or it completely fails. There is no possibility that one of the routing nodes can steal the money. And in the same way, we can have a Lightning path where a route where is, let's say, circular, where we send Bitcoin on one side, we do routing of Bitcoin for a while, then at some point there will be a node on the other side that receive Bitcoin and send, in this example, USDT. So, so effectively, these two, okay, the two guys at the opposite side of the screen, they're operating a swap with each other. The first lady sent Bitcoin, and at the end received the USDT, and the guy on the right received Bitcoin and sent USDT. So of course they need to agree on an exchange rate. So this solves settlement. Then price discovery can be done in multiple ways, but then you have atomic settlement of trades on top of Lightning. And this is like quite powerful because it's such a better trading experience than traditional DEXs on, other DEXs on other EVM chains, because you don't need to pay on-chain fees. You have very low latency. If you have direct Lightning channels, it can be like 1 second or maybe even lower if you have very good connection. There is no front running, nobody else sees what is happening. Also the guys doing routing here, they only see that they're routing Bitcoin in the above case, or they're routing Tether. They have no idea that there is a swap happening in the payments they're routing. So nobody can see what you're doing, nobody can front run you, unlike EVM chains where miners or flash bots can front run you. And you also have certainty on the price, so you know at which price the trade will be executed. So it's a much better alternative to liquidity pool. And by the way, we also have a workshop in the afternoon in the other room where we will go a bit more into details of how this works and how this is being implemented. Common question, is all of this good for Bitcoin? Is it bad for Bitcoin? Well, like mostly I would say that it doesn't really matter for Bitcoin. This is something that leverages Bitcoin as it is. It doesn't attempt to change Bitcoin. It's just use Bitcoin transaction and give extra meaning. So yeah, I wouldn't say, that is either bad or good. But still, there are a few reasons why you could argue that it's good for Bitcoin. First of all, like if we have not only if people use Bitcoin not only to pay in Bitcoin, but also to pay in other assets like in stablecoin that are quite popular for payments, you have a shared infrastructure cost. So for example, let's say that we have a merchant that install a payment terminal that accepts USDT on Lightning. With the same thing, you can reasonably also accept, it's the same tech that you need to accept Bitcoin on Lightning. So you can make a Bitcoin on adoption much easier without extra friction that you have right now when you need to move from card payments to Bitcoin. Then it brings decentralized trading on Bitcoin. So if you're a Bitcoiner, you want to hedge your position or bet against the US dollar or whatever, you can do it directly on Bitcoin without having to go to centralized exchanges or to other altcoins. And it brings volumes to Lightning node operators and in general Lightning service provider as well. So if we have more payment volumes happening on Lightning, it means a Lightning node operator with the same infrastructure cost can have more revenue. So it means that it can afford better infrastructure, which is good also for the people using them only for the Bitcoin part, that they don't care about the RGB part. And is good also for a Lightning service provider, because they can have more revenues as they also handle all the stablecoin volumes and the trading volume that can happen on the DEX side of this. And this helps them to have more revenues to keep developing a better solution for lighting service lighting service provider infrastructure, and makes the user experience of using lighting better also for those that care only about Bitcoin. They don't care about RGB. So overall, I believe we can believe that it's a net good for Bitcoin. And I mean, you may argue that this point may be valid or not, but for sure it's not bad for Bitcoin, because it doesn't change Bitcoin in any way. It doesn't change the security model. So yeah. So the RGB ecosystem is quite diverse. It's not only the project of one company with venture capital money that needs to overpromise every time to make the next round of fundraising. It's a project of multiple companies with different objectives, different source of fundings that are working together to create an industry standard. So yeah, it's not only us in Bitfinex. There are many other entities and companies and individuals that I didn't put the logo on. I cannot put mention all the individuals, but there are also individual contributors that work or worked on RGB. So yeah, RGB ecosystem is already becoming quite diverse, which is very good for the resilience of the protocol and the long-term sustainability, because it's not that it's one company with VC money that if the next round fails, then nobody maintains the protocol anymore. If any of these companies decide to stop working on RGB, I mean, RGB will still go on. So yeah, that's the end of my presentation. You already showed you the link to the lighting node. Here, if you want to try the Android app has no lighting, it's only on chain, but it's easier to play around. And here is also a website to get some general information about RGB. So thank you for your attention.